with another lesson in electrical and electronic principles. In this lesson, talking about units and prefixes. Some of you are struggling with units, and so this is a simple lesson. Very quickly, just go through the units and their symbols and their prefixes. Units, they are something that we're all familiar with. This is an international system of units called SI system, or System International, which we use to make life easier. Prefixes, we use a prefix to make numbers easier to handle. It's basically a letter that goes between the number and the unit. I'll show you examples. Let's say, first of all, let's just introduce the quantities, symbols, and their names. So if you have a quantity of, for instance, length, the symbol for it is meter, the name for it is meter, symbol for it is m. Mass is measured in kilograms or kg. Time is measured in seconds or s. These are units used in SI system. The other systems might use other things. For instance, mass in Old British is measured in pounds instead of kilogram. But we are complying with the SI system nowadays, and we have to learn these things. So time is seconds, and S is the symbol for it. Temperature, Kelvin, K. Force, Newton, N. Power, watts or watt, and W. Voltage or potential difference, or EMF, electromotive force. They're all the same thing, but just different terms used for it. And it's measured in volts, and the symbol for it is V. Current is ampere or amperes, and the symbol for it is A. Resistance is measured in ohms or ohm, and the symbol for it is this omega. Capacitance is measured in farad or farads, and F is the symbol for it. Charge in coulomb, and C is the symbol for it. Magnetic flux density, Tesla, and T symbol is the symbol for it. Now, a prefix, like I said, makes life easier. For example, if you have a frequency like this, the radio frequency of radio 1 is 97,700,000 hertz. Now, imagine we keep talking about these values on a daily basis, and if we were to write and talk about them like this, 97,700,000 hertz, that just takes time and space and waste energy. So, or electrical consumption of UK in 2007 is this many millions or billions of watt hour. If we had to write numbers like this, it would just basically, the documents and books would be huge. We would waste a lot of time and effort to just do this. Constantly writing numbers like this also means mistakes are also more likely to happen. With prefixes, though, we can write them like this. Frequency of radio 1, instead of saying this, you can say 97.7 megahertz. Electricity consumption of UK in 2007 is 400 terawatt hour. Much nicer and easy, isn't it? So, how do we do this? You need to know about standard form first. We call this standard form. Let's see what a standard form is. When we say 100, 100 is 10 times 10. 10 times 10 times 10 is 1,000. 10 times 10 times 10 times 10 is 10,000. It's still manageable, but it gets crazy when it gets bigger and bigger. So we decided we write this, instead of saying, it's just basically the powers of 10. So you say, instead of saying 100, you can say 10 to the power of 2. Or instead of writing 10 times 10, you can say 10 to the power of 2. Instead of writing 10 times 10 times 10, you say 10 to the power of 3. So all that power means is that this number is raised by that power. In other words, this number is times by itself that many times, right? Now, you can use this system to write big numbers in an easier to manage way. For example, 8,000 is the same as 8 times 1,000, and 1,000 is the same as 10 to the power of 3. So we can say 8,000 equals to 8 times 10 to the power of 3, and that is the standard form. We call that standard form. So we can write, for instance, more examples. 900,000 is 9 times 100,000, and that is 9 times 10 to the power of 5. Or 2 million is 2 times 1 million, and 1 million is 10 to the power of 6. So we can say 2 times 10 to the power of 6. Or 500 is 5 times 100, and that is 5 times 10 to the power of 2. Do be careful though. 12,000 is 12 times 1,000, and that is 12 times 10 to the power of 3. Is that a standard form? Is that how we write it? No. We write 1.2 times 10 to the power of 4. We have to have one complete digit before the decimal point. So, for instance, if you have 12,500, you write 1.25 times 10,000, and that is 10 to the power of 4. Or this one, you have 6 zeros in front of 95. You go 9.5 with 6 zeros in front of it. Instead of 6 zeros, you say times 1 million, and that is 9.5 times 10 to the power of 7. Because you have 6 zeros and a 1, so you have 7 digits, really. I'll explain that later a little bit. 405,344 is 4.05344 times 100,000, and that is 4.05. We rounded that, the rest of it, times 10 to the power of 5.